This video explains how to account for base flow in from a total runoff hydrograph. The following is a total runoff hydrograph. This hydrograph is used to was determined from measurements at a stream or river gauging station. The lowest point on the hydrograph, as highlighted with the red dot, is the point where direct runoff starts. The time is referred to the start time, or TS. If we were to make a straight line from TS to the point where the line intersects the hydrograph, this method is referred to as the constant discharge method. And the point at which it intersects is referred to as TE, or the end time. We can then write the base flow equation as follows. The base flow is equal to Q, total runoff, when T is less than or equal to the start time. QB is equal to the flow rate at the start when T is between TS and TE from the start to the end. And finally, the base flow is again equal to the total runoff Q when T is greater than TE. The highlighted line represents the division between the direct runoff and base flow. The bottom section refers to the base flow, while the top represents the direct flow. The overall flow rate, QT, is equal to the base flow, QB, plus the direct runoff. So let's do an example. You are given a total runoff hydrograph as shown here. You have 7 hours of data with flow rates. We're going to sketch this graph. So we're going to create a graph that shows time as a function of flow rate. Next, for every point, we're going to put a dot on the graph. So at time 0, we'll have 0. At time 0, we'll have 100 cubic feet per second. At time 1 hour, we'll have 90. At time 2 hours, we'll have 85, and so on. Then we will connect the dots to create the hydrograph. Now we're going to construct the equations. So the start time occurs at 2 hours. The end time will occur somewhere between 6 and 7 hours. In order to determine when that end time occurs, we will have to interpolate, as shown. The time at which the constant discharge line intersects the hydrograph is at 6.4 hours. Next, we need to construct the base flow equations. So, the following shows you the actual equation for this example. Q base flow is equal to the total flow rate when T is less than 2 hours. Q base flow is equal to 85 when T is between 2 and 6.4 hours. And base flow is equal to the total discharge again when T is greater than 6.4 hours. So let's take the hydrograph, the total runoff hydrograph, and let's add to it a column for base flow and direct flow. At time 0, our flow rate is 100, our base flow is 100. Therefore, our direct runoff is 0, 100 minus 100. At time 1 hour, our base flow is 90, and our direct flow is 0, because 90 minus 90 is 0, and so on. At hour 3, our total is 150. However, our base flow is 85 and our direct runoff is 65. If we continue repeating this, we will be able to calculate both the base flow for every time step and the direct runoff. Next, we want to calculate the volume of direct runoff. This is the area under the curve. which is highlighted in green as shown. Now, there are many methods we could use to calculate it. We're going to use the rectangular rule to determine this volume. So the following depicts how to calculate the volume of the green area. The volume, dr, is equal to 65 plus 0 divided by 2 times 2 hours. We're going to repeat this for every area, as shown. Then, because we're in cubic feet and hours, we will do unit conversions, and we will calculate a direct runoff volume of 975,600 cubic feet, which can also be referred to as 22.4 acre feet of volume. We will do more examples in class to further solidify this concept.